The next one here is one that comes from Ndlovu, Pina Ndlovu. This one looks like it's a question that comes from, what's this? It's calculus. Yes, it's differential calculus. So how does calculus even begin? Not complicated, very basic and straightforward. So I'm going to start with 7.2 to demonstrate the rules of differentiation. What I want to highlight with the rules of differentiation is respect what they're asking. They may ask you y equals to something. If they say derive, you'll do dy over dx, okay, as the solution. If they give you f of x or g of x, when you derive, you'll say f prime of x equals, just maintain the correct notation. If they put d of x, just keep the stuff in the bracket with the dx outside until you are ready to derive. When you do the derivation, then you ignore the dx. Notation is big business. At some point, they told us to penalize matrix for not following correct notation. So I'm going to start with 7.2, which says find the derivative, okay, of what? Of 4x, right, plus 5, where everything has to be squared. All right, I can see it. I hope you guys can also see what is going on. Now, the idea with the power rule is we need everything to be in the form coefficient, base, exponent. They all need to be in that form, all right? If they're all in this form, we can then find the derivative because everybody knows the drill. Exponent times coefficient, exponent minus 1. That's the idea all the time. Okay, so now it's not ready for differentiation. What do? I just fix it. I'm going to keep this dx here, and then you're squaring a binomial. You can put two brackets, 4x plus 5. Please don't write 16x squared, and then you write plus 25. If you do this, it's going to be wrong because you're just squaring the first term and squaring the second term. When we square binomial, grade 12s, very important for you to understand that it is not going to be the first thing squared and the second thing squared. It's always a squared plus 2ab plus b squared. If you're not sure, just put two brackets and work with them. So what does that mean? That means there's something that is missing here. I hope this thing is going to work out. It's not going to work out, okay? That means the 25 has to shift. We need something there in the middle, all right? Where will 25 go? 25 is going to go there. Let's put 25 here, okay? So we need a middle term here. The middle term is what you get when you multiply these two terms and then you double them. So 4 times 5 is 20. If you double 20, you're going to get 40 of x's, right? Now, my function is ready to be derived, so I'm going to do the derivation. When you derive, you drop the dx. Product of 16 and 2 is 32x. Product of 1 and 40 is 40. The derivative of a constant, you guys should know it is always a 0. No complications. Let's go to the last one. The last one looks much more exciting. Much more exciting. They're saying to us here, we have to find dy over dx if y is the fourth root, okay? Let's copy that down, 7.2.2. So y is the fourth root, okay, of x, right? Plus, now this is where it becomes exciting, x squared plus 8 over x squared, okay? Now we need to find the derivative of this. Remember what I said, everything needs to be coefficient, base, exponent. This is what we want to find, okay? Now the first one is insert form. We just need to convert it to exponential form. Please don't put dy over dx now. We are not yet deriving. This would be a mistake. What are you looking at? You're still looking at y, not dy over dx, all right? Now the root of x to the power, the fourth root of x is going to be x to the power of whatever the exponent you have inside over whatever the exponent, the root value you've got outside. So it's 1 divided by 4, okay? Plus. Now here, my algebra comes in again. If you have a plus b divided by c, you can split this to a over c plus b over c. You guys need to understand these basics, algebra and substitution and solutions of equations. Those three things are big in your math. As long as your basics are okay and you can do solutions of equations, you will definitely do well in this paper. Very powerful. So I'm going to apply this idea on this. So I'm going to split the denominator. I'll get x squared on x squared. I'll get 8 on x squared. What does this become? My y becomes x to a quarter plus 1, okay? Plus, now this is in the wrong place. Obviously, we take it up, it becomes x to the power negative 2. Now I'm ready to derive. Only now do I then say the derivative of y with respect to x is a quarter of 1 is going to be a quarter x to the power. A quarter minus 1, it's like 1 over 4 minus 4 over 4. It's going to give you negative 3 quarters. The derivative of 1, which is a constant, is going to be 0. The derivative of 8x to the negative 2 will be minus, that's 16x to the negative 3. Now, you can leave it here if nobody says anything to you and run away after it. Or if they force you to write it with positive exponent, you just need to take back those x's underground. So it's going to be 1 over 4. X to the power positive 3 quarters minus 16 over x to the power of positive 3. You don't have to do that if no one asks you, but it's just good practice for you to do this all the time because it actually helps you in terms of practicing, because then from here you know definitely in future if anybody forces you to do that, you'll be up and running parallel to yourself and you won't have any problems to actually find the solutions.